Hi and welcome to this video where I'm going to calculate the correlation coefficient using a pen on paper method. Now there's a very good chance that this video will be split into two, maybe even three parts. I've got a few things to talk about and I want to take you through the entire process pen on paper. But in an exam situation you probably wouldn't have to do the entire process pen on paper, and I want to make that clear. You should have learned in class how to do it on your calculator, or you will learn soon. But for now I'll take you through each step and try and break it up into those parts. You may end up just having to do one part of that in the exam. First of all, here's some formulas, okay? This is the formula we're probably going to use the most, and it's also the one in your textbook. Here's this little beauty that's in, it should be back on the end now. This one is on the formula sheet. So you're going to want to get used to this one, but we actually think this one works better. And the reason is this. There's lots of notations here that you won't quite know. But this Sx is the sample standard deviation for x, and in Unit 2 you will have learnt about Sx. And this is how we calculate standard deviations. It is almost certainly going to be a pretty horrible number. That's fine, because when you calculate Sx you get your horrible number, Sxy you get probably a horrible number as well, Sy a horrible number. You put three horrible numbers into the final equation and you work it out, which is doable. The problem we have with this one down here is that before you even do any summing, you're dividing by a horrible number for each individual term, and it does get a bit out of hand. So just be warned, this formula here can make things hard. That's not in the formula sheet though. You could use this to work that out. So there's your other option. So I would take that and get used to working this out from that, or memorize this, or whatever it is that works best for you. Okay? So first of all, we have a set of data. This is bivariate data. So it means we've got a relationship, or we're testing a relationship between x and y. 2 and 4, 3 and 5. If I do a quick sketch of this data, and it's going to be rough because it's on a whiteboard, but you could do a better sketch on your in your book. 2, 4, it has to go up to 14. 2, 4 is about there. 3, 5 is a bit higher up. 7, 10 is about there. 8, 14 is about here, and 1, 3 is about there. And so it's only 5 pieces of data. Don't forget that. It's a very small set of data to be making any assertions about, but I can see that it's pretty approximately linear. Okay, that's going to follow a linear curve reasonably well. I'm expecting to get a decent R value out of this. So just keep that in mind. But I'm going to do the full calculation now. So I will probably cut this video now, and I'm going to go into a video about finding the standard deviation.